Hello everyone. In this video, I will explain optimization, some types of questions. Optimization is a very long topic. We have different types of questions. I will be solving 20 questions, so it will take a couple of videos. And to solve optimization questions, first we need to know what's given and what's unknown. And by using the given and asked, we are going to write an equation. In this equation, we will have two unknowns, so two different variables. We will reduce the equation down to one single variable and take the derivative, because the question will say what is the x value that makes the area maximum or minimum, or volume or distance or whatever. So we are going to be asked about finding the x values that are maximizing or minimizing the given amount, the volume or radius or area or whatever. So we will be taking the first derivative. But first we are going to write the equation, reduce the two variable down to a single variable, then take the first derivative, find x. We have many different types of questions. Some questions have fast ways, some types of the questions have fast ways, but I'm not going to use the fast ways. Some questions that are easy to solve, that are simple, that are short, then I will just solve questions, the long step questions, by using the fast way. There's also a lot of memorization here. We have different formulas for every type of question. Maybe we'll have different formula, so you have to memorize the formula. But for the fast way, I don't suggest you to memorize the fast ways of every type of question. For the questions that can be solvable in a simple way, you don't need to apply a fast way, you can just solve it. So let's start with the first type of question. First exercise and a ministry question. Find two numbers so that the sum of the first and twice the second is 100 and their product is maximum. So whenever the question says something is maximum or minimum, it's actually talking about the first derivative. Remember, we have a maximum point or a minimum point when the first derivative is equal to 0 or undefined, right? So from that idea, we are going to equalize the first derivative to 0. Derivative of what? Derivative of products. Product of what? Two numbers. What are those two numbers? Let's say one of them is x and the other one is sum of the first and twice the second. Let's say the other one is y. We have two different values. Sum of the first and twice the second is equal to 100. Question is asking about their product to be maximum. So we are looking for derivative of product to be 0. Okay. So in order to get the product, I will write the equation first. I wrote the first equation, the sum equation, according to the given. But in this equation, I have two unknowns. So let's reduce the two unknowns into one. Let's get x in terms of y, for example. Bring 2y to the other side. X is equal to 100 minus 2y. That's the sum, right? What we need is products. What is product? Product means multiplication, x multiplied by y. So we wrote x in terms of y from the previous equation, which is 100 minus 2y. So x, which is 100 minus 2y multiplied by y, let's simplify this. It's going to be 100y minus 2y squared. I get product by using a single variable. Now it's time to find derivative of product and equalize it to 0 to find unknown. So I need p prime. So p prime equals derivative of 100y is 100 minus derivative of 2y squared is 4y. It's supposed to be 0. Bring 4y to the other side. Divide both sides by 4. Y will be 25. I am looking for two numbers, which are x and y. I got y, now I'm gonna find x. How do I find x? I know that x is 100 minus 2y, right? X is equal to 100 minus 2 times y, which is 25. 2 times 25 is 50. 100 minus 50 is 50. So I got my two numbers, one of which is 25, the other one is 50. Okay, this is the way. Okay, let me summarize what I did. First of all, I wrote an equation by using the given. We were given two numbers whose sum is 100. First and twice the second is 100. And I isolated one of the variables, write them in terms of each other, and I asked the equation of the asked. What was asked? The product was asked. I wrote its equation, which is x times y. I wrote x in place in terms of y by using the previous thing that I isolated. And I got my asked equation, and I took its derivative because it was asking about the maximum product being maximum. I took the derivative and equalized it to 0 and find the value. By putting this back into the equation, I got the other value. So this is how I solved the question. So for the rest of the questions and optimization, these are the steps that we will follow. Okay, let's move on. Second question, similar type of a question, exercise 2. Find two positive numbers, let's say x and y, whose product is 192. So this is the given information. So by using this given information, write the equation. What is the equation? The product is being 192. Product of what? Two positive numbers, which are x and y. So x multiplied by y is given as 192. And what is asked? Sum of the first, let's say the first one is x, plus, and 3 times the second. 3 times the second is going to be minimum. So I'm asked to find s prime then. Okay, so like we did in the previous question, we will isolate one of the variables by using the first equation first. Let's isolate x, for example. X is equal to 192 over y. Now put this 192 over y in place of x in the second equation. So let's say s is equal to x, which is 192 over y plus 3y. And finally, I'll take the derivative of this sum because I need my sum to be minimum. Minimum, maximum means derivative. So we will take the derivative of this s. So let's take its derivative. S prime equals negative 500. Here I have derivative 192 over y squared. Derivative of 3y is plus 3. I need this to be equal to 0. Now let's bring 3 to the other side, or negative 192 over y squared to the other side. 192 over y squared equals 3. Cross multiply. 192 is 3y squared. Divide both sides by 3. Y squared will be 64. So take square root of both sides, y will be 8. I got y. So what is next? Finding x is the next step. So by just substituting the y value for y in the equation for x, I will find x. X is 192 over y, which is 8. So that will give me 24, right? So I got two numbers, which are 24 and 8. So we follow exactly the same steps given by using the given information. We wrote the equation. For the thing that is asked, we wrote another equation. So we took the derivative of the second equation after we simplified the variables, reduced the variables down to a single variable, and take derivative equalize to 0, find the values. Steps are simple. Okay, let's continue with another type of question. Find the length and width of rectangle so that its perimeter is 100 meter and it has a maximum area. So it's a perimeter question, exercise 4. So we need area to be maximum. So we are looking for a prime, right? Derivative of area. But first, let's write the equation by using the given. Length and width of the rectangle is per meter is. Per meter is given as 100 meter, which is, remember the per meter formula, 2L plus 2W, right? 2 times length plus 2 times width is the per meter formula for rectangle. So let's solve it for one of the variables. Let's solve it for L, for example. L is 100 minus 2W over 2. Or when you simplify this, 50 minus W. So length is 50 minus width. Now, let's apply this in the area formula. What was the area of a rectangle? It's length times width, right? In place of length, we can write 50 minus width multiplied by width, which is 50 width minus width squared. Now, next step would be taking the derivative of area. So A prime equals 50 minus 2W, which is supposed to be 0, 2W to the other side. So width is equal to 25. What about the length? By putting this width in the length formula, we will find the length. 50 minus width, which is 25, also 25. So our length is 25, width is 25. Okay, so in order to solve this question, you need to know the formula of finding the area and the perimeter of rectangle. All right. So there is a fast way for these type of questions. We can say the length and the width for these type of questions is perimeter divided by 4. Our perimeter is 100. 100 divided by 4, 25, which is for both length and width. Okay. Next type of question, fence questions, exercise 8. A farmer plans to fence a rectangle posture adjacent to a river. So, what is the difference between this fence type question and the rectangle? In the rectangle, we have 4 sides, right? So in the fence questions, we have 3 sides because the third side is adjacent to river. The area of posture must contain 180,000 meters squared. So first of all, let's write the equation by using the given information. We have area, we are talking about area. Area of this fence is like the rectangle. It's x times y, length times width. This is given in the question as 180,000 meters squared. What is the question? What is asked? What dimensions would require? Dimensions. It's talking about width and length, which are x and y. So we are looking for x and y. In which condition we are looking for this? Which require the least amount of fencing if no fencing is needed along the river. We are looking for the dimensions that require the least amount of fencing. This actually means what happens to the dimensions when perimeter is least, meaning derivative of perimeter is 0. Okay, least, lowest, greatest, smallest, maximum, minimum, they all mean the derivative. So we are going to take derivative of perimeter equalized to 0 to find the dimensions. So first of all, let's figure out what the perimeter of the fence is. When you look at the fence, we have two widths, two L, two Y, let's say, plus one length, X. So in rectangle, we had 2y plus 2x, but in fence, we have 2y plus only 1x because the other one is adjacent to the river. So we are going to find this equation after we get one of the variables in terms of the other. So let's isolate x or y. Let's isolate y this time. So y is equal to 180,000 divided by x. So in the perimeter equation, we are going to insert 180,000 over x. Let's do the opposite. I changed my mind. Let me isolate x. So 2y plus x, which become over y. Now I need p prime to be 0. So let's take derivative of this perimeter, which is 2 plus or minus derivative of this is negative 180,000 divided by y squared, right? Okay, I got the derivative, equalize it to 0 and solve it. So 2 is equal to 180,000 over y squared, cross multiply, 2y squared equals 180,000, divide both sides by 2, y squared is 19,000, take square root of both sides, y will be 300. Okay, I got one of the unknowns. Now get the other unknown. I get the width. Now I'm gonna find the length, which is x. That is 180,000 divided by y, which is over 300, which will give me 600. So I got x, I got y, I got the dimensions. Okay, there's of course a fast way for fence questions. The x, the length, is square root of 2 times area, and the width is square root of area over 2 if you wanna use fast way, but I don't recommend because there are 20 different types of questions, so it's impossible to memorize all of them. I wrote anyway. Okay, another type of question. Check it out for paper questions. The solution will be kind of long, but it is easy. The idea is easy because a graphic designer is planning to design a rectangular page that should contain 200 centimeters squared of print. So we are looking for area of the print. So what part is the area of print? When you look at this figure, only the writing parts, the writings, will be the print area, this part. So what is the area of this rectangular part? Our length is x, width is y. So area of print will be x times y. So in the question we are given x times y as 200. And what is the question? Each of the four margins is 3 centimeter wide, as you can see. What should the dimensions of the page? It's asking about dimensions of the page, not the print, the page. So for the page, the dimensions, the length for the page is x plus 3. So it's x plus 6. And for the width, it's not just y, it's the print dimension. It's the dimensions of the page is y plus the margins 336, y plus 6. So the question is asking about x plus 6 and y plus 6. In which condition we are going to find these dimensions? When the least amount of paper is used. The least amount of paper is used means the derivative of the page will be 0, right? In order to use the least amount of paper, the derivative of the paper, the area of the derivative of the paper should be 0. So what is the area of the paper? Area of the paper is y plus the margins times x plus the margins. In this question, area of paper is x plus the margins, x plus 6 times y plus the margins, y plus 6. So that's what we are looking for. The first of all, we should reduce the two variables into one variable by using the given information. So x times y is 200. Let's isolate one of them. X is equal to 200 over y. So in the area of paper formula, we are going to write x plus 6, which is, I cannot fit in here. Let me go down. Okay, area of paper is x plus 6 times y plus 6. So in this equation, x will be 200 over y plus 6, and y is y plus 6. So that's the area. Now I'm going to take derivative of this area. So let's take the derivative. So area prime will be equal to derivative of 200 over y is negative 200 over y squared. Derivative of first is this times second, or let me simplify the equation first and take derivative. Maybe in this way it's easier. Okay, area will be distributed. It's gonna be 200 plus 2 times 6, 12 over y plus 6y plus 36. I think it's easier to take derivative now. So area prime equals derivative of 200 is 0. Derivative of this is negative 1200 divided by y squared plus derivative of 6y is 6. Derivative of 36 is 0. It's supposed to be equal to 0. So let's bring 6 to the other side, or this fraction to the other side. Okay, 1200 divided by y squared equals 6. Cross multiply. Divide both sides by 6. So y will be 10 square root of 2, right? Which will be approximately 14. Approximately. Okay, what about x? Okay, let's take a look at x. X is equal to, what did I say about x in the beginning? I said x is 200 over y. X is equal to 200 over y, 200 over 14, which is equal to approximately 14 again. So I got x, I got y. What was the question? Question was asking about the dimensions of the page, which are x plus 6 and y plus 6. X plus 6 is 14 plus 6, which is 20, y plus 6 is also 14 plus 6, which is 20. So these are the dimensions of the page. Okay, there's of course fast way. The width of the page can be found by using y plus 2a. Width of the print is y is equal to a print over x. Length of the page is x plus 2b. Length of the print will be b times area of print over a under radical. But I think this first way is more confusing than solving the question. All right. I'm not done. I have another type of question, an open box question. Check it out. One. An open box of maximum volume is to be made from a square piece of material. An open box of maximum volume. So what is the volume of the box? So this is the first thing to know. What is the volume of the box? We consider this a three-dimensional figure uh, when you fold the paper to make a box. It's gonna be length times width times height, right? So base area times height. What is base area? 24 minus 2x. We have 24 minus 2x, and this part is also 24 minus 2x, and this folded part is x. So we have 24 minus 2x times 24 minus 2x, which is 24 minus 2x squared, multiplied by x. So that's the volume. In this question, unlike the others, we have only one variable. So no need to write one variable in terms of the other. I think this is easier type. So now, let's continue reading the question. An open box of maximum volume is to be made. Maximum volume means the volume prime being equal to 0. So I'm just going to take derivative of this and equalize it to 0. 24 cm on the side by cutting equal. It's describing how to get the box. What value of x should be chosen to have the maximum possible value. So when we equalize the volume prime to 0, what will our x be? This is the question. So let's take derivative. Before we take derivative, let's simplify this equation. Volume is equal to 576x minus 96x squared plus 4x cubed, and take its derivative. V prime equals 576 minus 2 times 96 is 192x plus derivative of this is 12x squared is being equal to 0. I see a common factor is 12. Take 12 out or divide everything by 12. So we will get, let me order it, write it in general form, x squared minus 16x plus 48 is equal to 0. Factorize x for 12. So the middle term is negative, they will be all negative. So x minus 4, x minus 12 being equal to 0. So x is 4 and x is 12. We have two possible values. Are they both true? Do they both satisfy the equation? Let me see. If I choose 4 for x, what will happen to the volume? If x is 4, let's substitute 4 in the given equation, in the equation that I wrote. 24 minus 2 times 4 squared times 4. That will give me, when you calculate this, 124. Yes, it's possible. What about 12? Is 12 possible for this volume? Let's put it inside the equation. 24 minus 2 times 12 squared times 12, which will become 0. That's impossible. So we cannot have 0 volume. So my answer is only 4. x equals 4 makes the biggest volume for this open box question. Okay, open box questions are, I think, easy because there is only one variable in the equation, so no need to write one variable in terms of the other. Taking derivative and solving, the steps are pretty simple for this type of question. And there's of course a fast way. According to the fast way, x, what is asked in the question, will be equal to the length divided by 6. The length given in this question is 24. 24 divided by 6 is 4. You get the answer. Fast way is also easy for this type of questions.